In this lecture, I'm going to talk about how exercise programming and sports nutrition are directly connected. In sports nutrition, we don't create meal plans in isolation. Nutrition should always be based on how an athlete trains, including the type of sport, training intensity, duration, and goals. Understanding this connection is essential for creating nutrition plans that actually support performance, recovery, and long-term health. One of the most important concepts in both training and nutrition is that there is no one-size-fits-all plan. Training programs follow the principle of individuality, meaning each athlete's program must be tailored to their body, sport, and circumstances. The same principle applies to sports nutrition. Two athletes can train for the same sport, but still need different fueling strategies based on their training demands, recovery needs, and lifestyle. The ACSM guidelines help structure training programs, and they also give us a framework for understanding nutrition needs. Cardiovascular training increases carbohydrate and fluid needs, especially as intensity and duration increase. Strength training increases protein needs to support muscle repair and growth. Flexibility and neuromotor training may have lower energy demands, but still rely on adequate hydration and nutrient availability. Finally, recovery days require intentional fueling, not restriction, which we commonly see with athletes, to support adaptation and prevent overtraining. Because training drives nutrition needs, we must consider several key factors when creating a sports nutrition plan. These factors help us move away from generic advice and toward individualized fueling strategies that support both performance and health. The type of sport or activity matters. Endurance sports like soccer or running rely heavily on carbohydrates. Strength and power sports place greater emphasis on protein and total energy intake. Mixed demand sports require a balance of both. Training intensity also plays a role. As intensity increases from easy to hard, carbohydrate and fluid needs increase to support energy production as well as hydration. Duration of training or competition significantly affects fueling needs. Short sessions under 30 minutes may require minimal fueling, while sessions lasting over an hour often require planned carbohydrate and fluid intake before, during, and after exercise. Training frequency matters as well. Athletes training multiple times per week or even multiple times per day need higher total energy intake and more intentional recovery nutrition to prevent fatigue and injury. Nutrition strategies must also align with training goals. Performance, muscle gain, fitness, weight loss, and recovery all require different approaches to energy, carbohydrate, and protein intake. Timing of training is another key factor. Morning workouts may require pre-exercise fueling, while afternoon or evening sessions affect meal timing, carbohydrate availability, and recovery nutrition. Hydration and sweat loss are critical performance and safety considerations. Athletes need adequate fluid intake before, during, and after exercise, along with sodium replacement when sweat losses are high. Then recovery nutrition supports adaptation and prevents overtraining. This includes carbohydrates to restore glycogen, protein to repair muscle, and fluids with electrolytes to replace losses. The key takeaway from this presentation is simple but important. To create or evaluate a sports nutrition plan, you must first understand the athlete's exercise program. Just as effective training requires structure and planning, effective sports nutrition requires aligning fueling strategies with training demands. Therefore, in this course, it is important for you to understand these factors in order to create a individualized sports nutrition plan.